So the law of identity comes from a body experience. Okay. So the audio on those videos was really bad. I thought it was because I was using the laptop's mic, but then I used this USB thing that should be fine. And it doesn't seem to have worked too well. So I think maybe it's Movie Maker. That's all I have on this PC. So I don't know, I'd like to be able to use it, but maybe I can up the video recording quality or something. This is my Macintosh, which is back. And it's an older computer, but there's certainly nice things about it. Turns out it's going to be good to use for Skype and various other things. This is my work table and stuff over here. It's not clear. I'm unpacking onto it. Still have some boxes to unpack. That's my work table. Like, that's going to be clear enough. I can make a computer on there and stuff like that. Fun stuff like that. Have a little extra workspace. Like, I'm going to get all the maps from AAA, the places we went on this trip. And I want to tape them all together into a giant map and draw that line and put it on the roof, for example. The ceiling, I always get those mixed up, ceiling and roof. So the thing about the presuppositional apologetics is that, first of all, this is a perennial issue of mine. I've always liked this. I liked it back when I learned these arguments. And it's all a school of some cool people like Pascal that came up with the last gasp, right, of atheism, of Christianity. Probably the last gasp was people just not mentioning it too much, except for in private life. Yes. But, certainly I enjoy the philosophical ones, the people like Lewis Carroll might come up with. Not that I know of any good ones from him, but just logical games. It's illustrative. So the thing about Eric Hovind and company is that these are interesting questions. Where does logic come from? If you can't justify the axioms, why do you believe they're certainly true? I've talked about this, has been a topic of my whole channel, this relativistic skepticism. Is these issues, is that with skepticism is the proof that you're always going back to axioms. So you can use induction to see you're never going to get to the axiom. A lot of people have been like, no, we're eventually going to get there. And then they're going to, oh, we got there. We got that law of identity, A equals A. Now, A equals A is an interesting one because, these are tautologies. It's like if you set up a truth system, you can use it to build like a net. And it's an amazing thing that such nets could be useful, right? That's the amazing part. Not that they're actually axioms. I mean, A equals A is just a statement in a language. You can take something like that as axiomatic and you can build a thing we call the mathematics. You can take that and the law of induction and there's some other law. And you'll get a mathematics, right? Something, that's why there's all different kinds of mathematics. They have rules of what they count as mathematics. If you have those rules, there's a certain kind of consistency. But they don't, it ignores life, right? A equals A, for example, ignores life. What does that mean? Am I the same as I am a few minutes from now? No, I will have changed. Is the apple the same? Are all two apples the same? I'm going to say A is an apple. Apples are for jacks, and jacks like to eat apples, I guess. Does that mean all apples are the same when you say set a variable? So, it's these are tricks we play. And as a programmer, I play them all the time. It's like you want to simulate love interest on a computer program, like in The Sims. Well, if you can turn it into a number, if you can use a number as a metaphor for it. So, and there's lots of things that are implied by this that go beyond numbers, and that's why you basically have set theory as a more modern way of describing mathematics and what the consistency is all about and how numbers actually interact you know. And I think some of that is a realization that the number system itself does not quite have the kind of continuity of concept that we're hoped. It obviously is continuous by its definition, the real number line, and yet it's got these weird holes that make it look like that isn't the fundamental. There shouldn't be those glitches, basically. We should be counting things as a separate thing from this continuous number line, right? Numbers fitting on, there is a discrete number line where there's one and then the next thing is two. So, and I say this as somebody that loves calculus, which is a study of continuity, basically. And it enables physics. And that's the amazing thing. Why does it have anything to do? Well, the reason is because we came up with these principles with a brain that has been evolving along for millions of years to run a mammal body with eyes and in a physical world. So the things that it figured out, they have to do with the real physical world. What a crazy thing. So the law of identity comes from a body experience. I put this here, and it'll be there when I come back. If it's not there, I know somebody took it. That's a body experience, and that is what the law of identity is capturing, along with some other concepts, because it's an abstraction, right? Sets are abstractions from containers, and when you don't treat them like a physical container, they start to come up with some weird results, maybe results that you want, but in the case of Bertrand Russell's paradox, things that mathematicians didn't want to get. You start playing games with sets that contain themselves or all other sets, which in mathematics, like, why not? That's what a set is. It's not supposed to be a container. It's not really a container. But that sort of breaks the system. Turns out you're modeling a container, and this is something like Lakoff proves that it is a model for the kind of container experiences human bodies have, mammal bodies for that matter, but certainly human bodies. We have experiences with containers, and those experiences are what got mined and turned into mathematics. So these axioms are not at all absolute or universal. They're always in a context. And one I like a lot is this law of cause and effect. Because in mathematics, you create a tautology. You say, this is the way it is by definition. Okay, then that's absolutely true within mathematics. The context becomes mathematics, and the question becomes, well, how well does mathematics map to reality or not? But in a physical law or axiom like the law of cause and effect, well, how we think cause and effect works has been changing for longer than that's been called a law. There's more than one version, so you explain that. And you want to explain the changing laws, and it's like, if you want to say that it has to be a law and it's axiomatic, but we keep changing it, then you have to admit the one we have right now is not axiomatic. And what we've done is we're trying to make it an image of this axiomatic, perfect version of the law that by definition we could never discover. Why could we never discover it? Because it's abstracted from human experience, which is never ending. Okay. So the law of identity comes from a body experience.